All right, there we go.
GM.
Yeah, evening, I guess, as well, from my side anyway.
Yeah, good morning, good evening, everyone. Thanks for joining us today.
Mhm. Uh, let's give it a couple more seconds. I see people are joining in, both from X and from YouTube. Good news is, wherever you are watching this from, there's gonna be recordings both on X and in YouTube. But on YouTube, I think it's easier if you revisit it, especially if you're building with us on this Builders Challenge. I think YouTube is going to be very helpful to come back to. There's also, for those of you who haven't seen the first one, there is also a recording of the first one. This one is going to be similar in many ways, but we might keep it a little bit shorter. But David's going to be telling you all about this. To do a formal introduction, hi everyone, I'm Dennis. I'm responsible for ecosystem and community in Nosana, and I'm joined by our DevRel engineer, David, who's going to be telling you all about the Nosana Builders Challenge and different ways. I guess some tips and tricks on how to compete as well, and everything about the challenge that we have with ElizaOS. So, David, the floor is yours. Go ahead and tell us all about it.
Yes, sure. Indeed. Welcome, everyone. Today we'll be talking a little bit about the collaboration we're doing with ElizaOS Builders Challenge number 4. Where we're building AI agents and we're using ElizaOS in order to do our challenge. So we do these little challenges every quarter. We call them the Nosana Builders Challenge. And this time around, there's $3,000 worth of prizes up for grabs and $1,000 for first place. And all you have to do is learn how to build an agent, like the rest of the world is doing at the moment, and deploy it on Nosana. So as long as you build an agent using ElizaOS technology, you deploy it on Nosana, and you do some kind of collaboration, deep integration between the two, there's a good chance that you'll be able to win. So let's get started. First off, we'll do a little introduction about Nosana, and then we'll talk a little bit about ElizaOS and how to actually get started in deploying. Today we're talking about bridging the GPU gap, how I stopped worrying and learned how to love the blockchain. It's a little nod to Stanley Kubrick's film about atomic war, and that there was this technology that really was shaped to change the world, but then actually it managed to bring about some peace. So as many of you know, there's a little bit of a GPU shortage happening at the moment. There is a lot of AI models that are being deployed at the moment. As you can see here, ever since ChatGPT 3.5 came onto the scene, there's been almost 100,000 models that have been added. And this is a little bit of a late graph. So if anything, I'm pretty sure this number is double or triple of what it's showing here at the moment. But yeah, so on Hugging Face, I'm pretty sure it's up to 500,000 at the moment, just because of how much innovation money is being poured into space in order to not only make these AI models, LLMs, image generation models, video generation models, OCR, text-to-speech, speech-to-text, and everything in between better, more efficient to run on smaller hardware. But yeah, there's a ton of demand, as many of you know, at running all of these AI models, and that requires GPU compute. So this is also one of the interesting ones as well. I like this graph because it really goes to show about it's not only about how much AI models we have at the moment, but it's also about how much content we're generating with all of these models. So here you can see the reasoning versus non-reasoning token trends over time. And it really goes to show that ever since we had this reasoning explosion within LLMs, it's also starting to grow exponentially a little bit. And so it's showing that line go up and to the right. So there's a pretty good chance that this is not going to slow down for the foreseeable future, is the point that we're trying to make here. And like as many of you know, the reason that many of you are in this space for is because of the tool invocation. The tool invocation is really at the basis of all of these agents, right? So on one hand, you're able to talk to an LLM, and an LLM is able to generate tokens. You're able to communicate with it using natural language, but the LLM also has the ability to call programs, like what we call tool invocation. And as you can see here, like this graph starts in November of 2024, and it really shows that we're at the very beginning of what I think is going to be the bulk of inferencing in the future. Tool invocation is really talking to an LLM for information and advice, and having it then help you draft a document is fascinating and it's magical. But I really do think that most of the compute going forward will be tool invocations, and that's what really makes all of these agents so powerful. And yeah, we're lucky to be at the very beginning, and that we get to build out this infrastructure, this core infrastructure for how the following generations are going to use all of these tools. And so to come back a little bit with then what I was describing as the AI compute demand, but also as there's a limited GPU supply. So there is this growing wedge between what's actually available, what manufacturing is able to produce, and how much demand there is for all of this new compute that is coming online. So on one hand, like you have all of these companies who are buying then up all of the enterprise GPUs and making it very difficult for everyone to be able to actually also buy GPU compute for themselves in order to be able to run these models locally or in-house. And I like this quote by Karl Marx that says, "He who owns the means of production controls the means of generation. Capital accumulates not only in the land or factories, but also in VRAM." Just a little head nod that VRAM is really like where it's at the moment. The people who have the most VRAM are able to control the biggest, baddest flagship models, and VRAM is really the name of the game when we're talking about GPU compute and how large the models are and how intelligent the models are as well. And it also goes to show that like being able to control all of this compute is really also where all of the money flows into the pockets of the few. And at Nosana, we have a little bit of a different vision. So now with blockchain technologies, we're able to create decentralized physical infrastructure. This has been a term that has been come up a little bit in the past 2 years. And there are all of these different projects that are trying to then decentralize the way that we provide services to one another, and how we can have different stakeholders then in the way that we provide all of these services to each other by leveraging existing infrastructure and or deploying new infrastructure. So on one hand, you have these physical resource networks, for example, maybe energy networks. Think of if you have a solar panel at home, you'll be able to use some kind of blockchain protocol then to sell the energy back onto the grid. And I really like Helium, which allows you to deploy a 5G tower at home, and then sell that 5G hotspot to your community, and you're able to earn then a little bit by providing a service, by hosting a node within the Helium network. And so this also comes back to decentralized AI. So on top of all of that decentralized physical infrastructure that we're talking about, so not only do you have networks like Helium, but you also have compute networks such as Nosana, and that's a decentralized network of GPUs. You are able to then start creating decentralized AI as well. So on one hand, it's agent frameworks such as ElizaOS, or it's about being able to train models, or it's about coordinating all of these models, or it's about verification. It's being able to tag the training data, and the training data that is used in order to create a new model. And every time that model is used, and it references a part of that training data, there's a direct value transaction that flows then from the person who uses that generated content from the model back to the original person whose data was used in order to train the model. Within the decentralized AI space, there is really a hard push on how we can use these technologies to create more meaningful ways of distributing value that is created, because I think we can all agree that there is a ton of value that is being generated right now. These AI models are very powerful, and it's creating a lot of value. And right now, we're really trying to find ways of how we're able to distribute that using blockchain technology. So indeed, as I mentioned already, within the space as well, there's different kinds of compute networks. On one hand, Nosana then is really within the decentralized cloud category of GPUs. And our bread and butter is being able to host AI models for other companies. So indeed, the Nosana GPU cloud, it's distributed all across the world. It's mostly consumer GPUs. There's more than 300 million devices across the world that's just lying there at the moment, not being used. So there is the supply is there, like the VRAM is there. We just need to then actually aggregate it and then repackage it and like make it available to the world. Nosana makes GPUs affordable and accessible for everyone. We believe in open source. We're fully transparent. So oftentimes we, just like you have open source software, we like to think of Nosana as open source compute. And here's a list of all of the GPUs that are available at the moment. So we have from NVIDIA RTX 3090s all the way to NVIDIA H100s. And as you can see as well, the prices for each one. For a 5090, for example, it's 40 cents an hour. So here we can see the price for what it would cost to run Stable Diffusion, what it would cost to produce 1,000 images using Stable Diffusion on Nosana. It would cost 38, a little less than 20 cents compared to using a more traditional provider, because we don't actually have to pay labor costs. We don't have to pay for the maintenance of huge data centers. We are able to then provide the service much more cheaply compared to our competitors. So what's the secret sauce, you may ask? Honestly, the secret sauce is it's just a Docker runtime with a GPU attached to it. So it's not that much of a secret. If you know how to use Docker, if it runs on Docker, it can run on Nosana. So yeah, and when it comes to, you can use your traditional frameworks such as VLLM, Olama, or if you want to run the Jupyter notebook, or if you want to run Comfy UI, all of these usually already run in a Docker container anyways. So it's just about then adjusting the parameters so that you can deploy Qwen, GPT, or Flux. And we think there's a really good fit as well here for then all of these consumer GPUs and then medium-sized models. And we think that medium-sized models are a really good fit for all of these agentic workflows that are coming onto the market. They're a really good fit for all of those tool calls that we were talking about. And in that sense, we can see it's also a growing segment. So it's really a perfect marriage between what's coming onto the market, what's where the demand is, and where the supply is at. That allows us to really be able to generate a lot of value. So what are the downsides? If you want to run, for example, a flagship model, right here, like you can see that's a Qwen 3.5 397 billion parameter model. That's really like at the top of the game. That's comparable to, for example, a GPT-4 Unquantized, that would run you up to almost 1,200 gigabytes in VRAM. And yeah, that's almost impossible to be able to actually run it here on Nosana. You would need really beefy hardware, like that only most hyperscalers have available. So yeah, we're somewhat more limited to those small and medium-sized language models, for example, and they have to be quantized. And at the beginning as well, downloading the resources is a bit slow. So it's good for batching, and it's good for stateless applications. So it's really good for being able to serve models. Yeah, and we have smart contracts. That's really where like the matching engine of Nosana lives. So everything is really secured by the blockchain. All of the rules of the game are encoded into the smart contract. So it's not as if every time that you actually post a job to the network, that gets handled automatically by the Nosana Solana smart program. Yeah, and here as well, we can see a little bit of how it would look like. You as a user, you post a stable diffusion job, goes through the Nosana network, goes through then the smart contract, gets deployed on the Nosana GPU, and then you get a URL back. And here's a little bit of what the contract flow looks like. So this is then just like a high-level overview of all of the flows within the program of how it works. And here is also, as you can see, it's a little bit of the parameters, like the JSON files that we use in order to be able to deploy to Nosana. They're basically simple JSON files. If you know Docker, you know how to use this. As you can see, it's you have to specify just the Docker container image that you want to use. In this case, we're using VLLM. Here in the CMD, we're passing in this Hugging Face repo, Cyan Kiwi /Quen 3.5. It's a 27 billion parameter model, 4-bit quantized, and we run it on port 9000. We have to expose port 9000 as well. And it makes it a bit more easy as well to really deploy. So yeah, if you know Docker, you can find your way around a Nosana job definition file as well. So as I mentioned, indeed, like this is in collaboration with ElizaOS, and it's $3,000 in prizes. So yeah, like very excited to see what all of you will be building. Somebody is asking where you can find the documentation for this. You can find it at learn.nosana.com. Here you can learn all about deployments. You can also learn how to use our API, how to use the CLI, and our SDK as well. So you can also actually deploy directly to the Solana smart contracts, but we don't recommend that. That's really advanced. So you have then these 4 interfaces, and here as well, you can learn a little bit about deployments. And in order to learn more about the job definition file, you would need to go then here to jobs and go to the job definition intro. And here you can actually learn a bit more about the schema and what are the different parameters that are expected within the JSON file, and how to write your own JSON file as well, and more complex examples of how to open up the ports, how to do health checks in order to make sure that your container is running, how to pass that back in, how to get resources from Hugging Face, for example. So in this example, you can see we're actually downloading resources directly from then this Tiny Llama repository, and we're putting it in then the /data models directory. So yeah, learn.nosana.com is where you want to be at, like if you want to learn more about how to actually use Nosana. And we also have then deploy.nosana.com. So here you can do your own deployments as well. we airdrop credits once or twice a day to people who sign up. So do go to nosana.com/builderscredits and fill out the form. Do note that it is a one-time drop. So you only get $5 worth of credits once. And that's what you get to actually do the deployment. So when you do the deployment, make sure that you record it, and then make sure that the recording is then via the Nosana deployment. But yeah, let's quickly do a deployment so we can see what that looks like. Instead of only talking theory, here we can go to then deployments, create deployment, and we can select a template. So in this case, let's go for a let's go for this PyTorch notebook. Let's run it on this 4090. And yeah, I should have deployed it. We should be able to look at the logs. Okay, yeah, someone has picked up my job. And as we can see, the container is being downloaded. So yeah, as I mentioned, oftentimes the beginning can be a bit slow. But let's go here. While we wait, and we can kind of see another one that I'm already running. So I'm already running this other deployment right now. We called it an infinite strategy. So for example, for this particular model, I'm running Qwen 3.5, 4 billion parameters with a 5,000 token context window. Here we can see I'm running a health check to make sure that it's running correctly. Here we can see I have 4 different hosts running it for me at the moment. So you can see that it is host load balanced, and we are able to access it then via this one particular endpoint, which is then the this URL right here, which is running on port 9000. So if we go to that URL, we can see then if we go to /v1/models, we can see that we have Qwen 3.5 4 billion parameters running right here. And then we can do a post request, right, in order to actually talk to this. But yeah, just you would need to copy then this URL into then your environment configuration file in order to be able to talk to it. But let's go back to our deployments. Our Jupyter notebook should be up and ready. If we look at the logs, we can see, oh yeah, it's online. So when we go to this URL right here, we can start our experiment with Jupyter, and we have a legit GPU backing it. Nice. And let's quickly stop this deployment as well. So indeed, so to be able to actually participate, you have to go then via the Nosana Builders Challenge on superteam.fun. There you will find Nosana Builders Challenge. We should be on the first page right here. Otherwise, just search for it and then submit then via the super team page. And we're asking you to then deploy to fork the repository. Which you can find right here at github.com/Nosana CI/agent challenge. Fork the repository and work on it there yourself. In your forked repository, push back all of the changes back to your forked repository, and then submit the link for your forked repository into Superteam when you're finished. And here as well, you should be able to find the link in order to claim credits. As I mentioned, you have to use the ElizaOS framework in order to actually develop your agent, and you have to deploy it on Nosana and create a 1-minute video then of that deployment on Nosana of your agent. First prize is $1,000, second prize $750, third prize is $450, fourth prize is $200, and the rest are $100 each. If you happen to be in Singapore, we're running a workshop tomorrow, so that's also interesting for you to know if you are in the space. Yeah, we're looking for different kinds of interesting assistance. So one thing that I am particularly interested in is how can you use other kinds of models next to running your ElizaOS model. So we provide you then with a Qwen 3.5 endpoint. We provide you with an embedding endpoint, but what other kinds of model can you run next to your ElizaOS agents? Can you run, for example, an image generation model or maybe a video generation model? What are interesting things that you can do, make your agent do by deploying other kinds of models onto Nosana in order to be able to give your agent more interesting features. So that's where we're really going to score a lot of points are for the projects that do deployments on Nosana, like with their agents. And yeah, as I mentioned, it's pretty easy to get started with ElizaOS. It's just bun install it, and then ElizaOS from the directory, and you can start running, actually chat with the agent on localhost. We provide you some endpoints. Sometimes they do drop out, so please do let us know if they're not running well, and we'll quickly fix it. ElizaOS provides you with a bunch of plugins so to make your lives easier, so you don't have to do all of the hard work of re-implementing features that are already available to you. And to be able to actually run your agent, you would need to then actually build the container and publish it to Docker, and create then your ElizaOS job definition file with then the image for your specific Docker container, and either deploy it via the Nosana dashboard, as we saw right then, or then deploy it via the CLI, which is a bit more advanced. As you can see here, you have to fork the repository. It would be nice to have a front end for it as well. So just to be able to make your agent a bit more interesting to work with, you have to start then these following repositories: the agent challenge repository, the Nosana programs repository, the Nosana Kit repository, and the Nosana CLI repository. You have to make a social media post as well about the agent that you've built, and yeah, provide your GitHub repo as I mentioned, provide the deployment URL as well, a little description, and a 1-minute video. And I see that for the video, is it a product demo video or the Nosana deployment video? The part of the actual Nosana deployment it's just to show that it's running on Nosana. That's all we need to know. So that part, that can be very short, right? The rest of it would be nice to actually have it a product demo video. Yes. What else? I hope there are no restrictions on changing the forked repo name. I mean, I hope changing the name won't affect my. No, indeed, that won't. That's not an issue. You should be fine. We care about the content of things. We don't necessarily care about what labels you give it. Quick question. So the Nosana deployment cannot be auth protected. Probably it can. Like you can do private deployments as well, and you can build in some kind of auth protection. Then, but with the examples that we provide, they do not include auth protection. No, so that is really up to you in order to build that into then your Nosana deployments. Someone else asked, so I can self-host my Quen inference directly from Hugging Face? Yes, you can. What else? I think that's it. Yeah, the judging criteria. So yeah, these are then like the criterions that we're looking at. Technical implementation and the Nosana integration and the usefulness of the UX are the things that we're looking out for. And you can always go take a look at the ElizaOS documentation or the Nosana documentation in order to learn more on how to get started. No. Also, I would like to make a little call to action here as well about that we are doing the Nosana grants program as well. So you can apply for $5,000 to $50,000 worth in non-dilutive support. And that means a huge chunk of your grant will be in Nosana compute credits, and a part of it will also be then in USDC, SOL, or NOS tokens for you. And yeah, we're looking for people to be actually build on top of Nosana and to use Nosana as part of their core infrastructure. And to learn about the more about the grants program, you can go to grants.nosana.com to learn more. And yeah, thank you everyone for taking the time to take a look at Nosana, like to build on top of Nosana and to participate in the Builder Challenge. I wish everyone luck with whatever it is that you're building. We're very curious to see what you're building and what you will be submitting and how you're using ElizaOS. Thanks again to ElizaOS as well, like for participating with us in this challenge. And yeah, I wish all of you good luck.